Thank you, Ellen, for the invitation. Very excited to be here. And also, yeah, as I was mentioning, I'm trying now the OBS with 2 scenes, but at some point, whenever sharing sound, probably need to change that view. But anyway, okay, so yeah, so welcome to this talk, and which is going to be about a project that I'm working at the moment and for the past months, which is called Live Coding using Crowdsourced Sounds and a Virtual Agent. And it basically looks into the live coding practice, which is writing code in real time to create music using sounds from the cloud or crowdsourced sounds, but then also how it can be enhanced by using a virtual agent. And so I'm exploring that in this project. And for this, this talk, it is to present the work so far and the implications for HCI research. So, okay, I think I can do this. No. Okay, I need to go, I guess, here. Yeah, so a little bit about me. I'm a researcher, a practitioner, and as a lecturer. So my research looks into sound and music computing and HCI and the synergies between both, in particular looking into systems for music performance and focusing on collaborative and participatory systems, but also creating self-built tools for my own practice in live coding and participatory music as well. And that's why, this research and practice inform each other. And in terms of teaching, I'm currently teaching courses on audio electronics and DSP, but in the past, I've been also teaching courses on physical computing, audio programming, and HCI applied to sound and music computing systems, and so on. So a little bit about DMU, the Montfort University, and MTI2. So the Montfort University is based in the UK, in Leicester, and that's in Midlands, it's Midlands. And basically it has 27,000 students, more than 3,000 staff, and there are 4 faculties. One is on the arts, design, and humanities. Another is on business and law. Another is on health and life sciences. And finally, there is one on computing, engineering, and media, where I am based. And the university has a gold rating in the 2017 Teaching Excellence Framework. Oops, sorry about that. Yeah, I'm learning this. Going to here. So I'm also affiliated to the Music Technology and Innovation Institute for Sonic Creativity, MTI2. This is a research institute that was established in 1999 by Professor Lee Landy. And this research center is part of the Leicester Media School, which is a part of this faculty, Computer Engineering and Media. So the main topics that the scholars that are in this institute are investigating include new technologies for electroacoustic music and sonic art. And also we have related undergraduate and postgraduate courses, including one that we have launched very recently on a master level on music technology and innovation. And then we also conduct international research connected to this. You might have heard of this journal, Organized Sound, that was established also by Professor Lee Landy. And it's around electroacoustic music. And yeah, it's experimental music, music technology, quite related to electroacoustic music. And there is this forthcoming EMS 21, the electroacoustic music studies conference that is scheduled in this July. It was postponed from last year. So that's where I'm working. Okay, let's see if I'm doing now right the keyboard. Hold on, because yeah, maybe I can do it from here, that's easier. So about the project, as mentioned, this is a project that I've been working in the past months. This is an EPSRC HCI Network Plus grant project. And as partners, there are Eclectic, Leicester Has Space, LUISEC, Phonos, and MTI. And as collaborators, we do have Top Lab Barcelona, Flucoma, and Freesound. And I'll be unveiling a little bit how, the different collaborators and partners have been participating in the project. But as you can see, we've been conducting some workshops about the tool that we've been developing. So this is the team of the project. So there is Ángel Faraldo from Phonos, that is based, an organization based in Barcelona that organizes concerts and artistic events. Then Sam Roach from LUISEC. LUISEC is another organization that organizes workshops of experimental music, and Sam has been co-designing with me the workshops. Then we do have Richard Forrest and Tony Abbey from Leicester Hackspace. They've been helping and hosting one of the workshops, of the 3 workshops. And then Edouard Solav and Isa Ferry from Eclectic. This Eclectic is also an organization based in London that organize both workshops and concerts. And we've been also collaborating with them for one of the workshops and performance. So next, I'll give some context about this project, and then the system, how it works, the system that we've been developing in this project, outreach activities, and finally a discussion and conclusion. I can hear, is that?
That means people joining.
Okay, cool. Sorry, because I can't see, with this, I can see anything. Okay, so the context. So a little bit of context on, so AI and music is kind of an umbrella term, and we can find different angles and approaches, and from many years as well. One kind of approach is machine musicianship. And this approach is AI applied to computer music systems, where the systems have the ability to learn and evolve. And then here you can see 3 examples. One is Voyager from Lewis 2000, which is a system with the ability to improvise with a human improviser. Then the Continuator by Pachet. This system is able to learn and play with the performer's style. And another example is Shimon by Hoffman et al. Developed at Georgia Tech by Gil Weinberg. And it's about a robotic musician with the ability to improvise with humans. So these are some examples and one approach. Then we can also find, like in the NIME community, new interfaces for musical expression, machine learning applied to some systems, and that includes, for instance, embedded devices that incorporate machine learning models that have been trained, ranging from augmented acoustic instruments, so using already existing instruments and augmenting them with machine learning abilities, but then also creating new digital musical interfaces. Notably, Fibring and Sonami, there is a paper published last year at NIME, where they kind of express or present their work along several years, collaborating on these lines. And then also we can find machine learning toolkits for music, including the Wekinator as well by Fibring, MLLeap or Fluid Corpus Map, and many more. And these toolkits have been instrumental to allow NIME practitioners and instrument designers to kind of incorporate machine learning algorithms to their instruments. Then there is this approach called interactive machine learning, which comes from kind of a HCI approach and a human-centered approach, where there is this interactive experience of training the model and interactive with machine learning algorithms. And that has been explored and applied to music technology and NIMEs as a creative musical tool. So for instance, this same paper, Fibring and Sonami, They present this long-term co-design process from an interactive machine learning approach, but also we can find examples of in mobile music, for example, to train multi-user models using this musical practice. Then if we kind of dig into machine learning and live coding, we can also find examples. And there is this approach about machine listening, that basically the machine listens to what happens, and that implies music information retrieval, audio descriptors, and then taking decisions from that. And so here there are listed a few examples. Notably, Collins has been developing these ideas, and this is one example, algorithmic remix system. We can also find apiculture, which also includes hardware and sounds from the cloud. And then this is possible to mix in real time, but there are some decisions from machine listening happening in the system. And also Cacharpo is another live coding system that basically is a live coder companion that kind of listens to what the live coder is doing and then replies or reacts. And then another kind of approach is also generally the systems that explore machine learning and live coding. They are you do the training part as an offsite activity, but you can also find examples of systems that do online training during the performance. And here there are a couple mentioned, which is the MEGRA system and the SEMA system. SEMA is based on a web or interface. The MEGRA system is based on SuperCollider, and both the machine listening part and online training process have influenced the system I will be presenting in this talk. And just to mention other approaches to machine learning and live coding, there are, yes, apart from this machine listening, you can also find examples based on rule learning, or for instance, style generation from learning from many, many examples, or developing agents that learn and improvise in a live coding fashion, but learning from the other live coders, and even gamification in the sense of having the audience a say when they kind of experience the live coding or the agent, they can influence the agent. Okay, so this is kind of the background of the project, but also another part I wanted to present is the software, or well, the prototype or the system previous to the current MIRLCA system that I will talk about, that has also established a little bit or justifies the why of the present project. And so this is a live coding system, the MIRLC-Rep, well, it's MIRLC, Music Information Retrieval in Live Coding. And the idea of this project or prototype system, however you want to call it, is to provide an easy way to create live coding using cloud-based or crowd-based sounds. So the idea is to, in a way, use existing technologies already, but adapt them in a way that they can be used in a live coding scenario, and that they can be used by anyone. So it should be a very easy syntax and to use. And I have some examples here of how the syntax looks like, but you can just instantiate a class and then start to get sounds from the cloud. And when I say cloud in this case, it's from the website freesound.org, where you have a collection of almost 500,000 sounds. You can retrieve them by ID number, but also there is a pre-analysis made for you with all these audio descriptors. So then you can also query or request sounds based on these characteristics. So here we see examples of retrieving sounds by ID number, because as said, each sound has an ID number, but you can also retrieve a random sound or retrieve a sound by a tag, because it's also a folksonomy style of website where all the sounds have different tags associated. But then you can also retrieved by content. So you can be more specific and say, I want a sound that has a duration of 10 seconds or a sound of a duration of 1 second of key A, and be more specific. But in this case, you are searching sounds by their audio properties or audio features, if you like. And then also this is based on the Free Sound API. So then you can also request similar sounds from a target sound. And then that also can come with surprises. So with this system, we can listen now to a couple of examples of two live coders using the system and exploring this Free Sound database and using this language. I hope you can hear the sound. You let me know if that's not the case. And I'm pressing it now. Oops. Okay, sorry about that, because let me change something. That should go. Is it working now?
Yes.
Okay, this was one example by Jack Armitage. Basically, well, as you can see here, because this approach is using sounds from the cloud, it's a good practice to list all the sounds that you are using and crediting the authors, the original authors. And that's with this system, the MIRLCaut, it's created automatically once you finish with a session. You can see this as an online sampler that you just get some samples from the cloud and then you mix them, but you get a list at the end so you can attribute the work. And I'll show another example. So here you can see two approaches, but then the commonality is also that it's a sound-based approach or sound-based music, as Professor Lilandi describes in one of his books, which I mentioned later. What with the workshops, this might not be everybody's cup of tea. So this is already an approach of using sound samples from the cloud and creating music out of it. So it might be some of you are, prefer other type of music. So after this first version, there was a second version, which is quite based on first version, but it includes more automatic functions. And it's kind of the foundation also, all this experience for the next version, if you like. So one of the main problems of this approach is that, problems and challenge, like problems, but also say advantages, is that you get some serendipity or randomness in the kind of when you are downloading sounds from the clouds in a performance setting. That means that it might be that you get sounds that you don't want or you don't like, and then you need to deal that in performance time. So that's kind of one of the main issues of this approach. And I'll show an example here. This is a case of performance on noise music. So the expectation of this performance was to get all sounds related to noise or noise sounds, but not melodic sounds. And all of a sudden there is a sound of a guitar just started to play, and that was a little bit out of tune of the aesthetics of this performance. So I'll show a little example as well of what you perhaps like, the limitations of this approach.
Anna, I don't think we're hearing your sound. I think we're hearing you exhale through the microphone.
Do you hear it from the microphone or from the computer?
No,
I don't think. Yeah, we're not hearing sound. The only sound we hear is you breathing.
Oh no! So that was
very intimate.
what I was asking. So you haven't heard the 3 samples, okay?
We heard the
I think we heard a little bit of the first one and then nothing.
Really? So I haven't changed any settings. So you know what I'll do? Yeah, because hold on.
I think the issue is Zoom is trying to figure out what is noise. They have a noise canceling. If you do, I think do original sound. I don't know.
Same as system, you mean, or I'll do same as
screen.
Oh yeah,
that's share sound also checkbox.
I'll do that. So then I'll stop my attempt of using OBS. So I'll change that and go to normal. Yeah, I mean the OBS. Yeah, it has been promising, but not. And I'll do that share normal one. Okay.
Yeah, I think in OBS you would have to add your computer sound as a separate audio input that OBS would then like forward to Zoom. It's weird because like you turn OBS becomes like the funnel instead of Zoom for all the media to go through.
So now let me close also OBS because I think it's also interfering. Yeah. So now, do you hear now sound?
Yes. Yes.
Okay, so we'll maybe put it again just so you hear the guitar. So yeah, so this basically, in this context, this guitar sound, it was out of tune basically. So that kind of justifies or has kind of driven to the project that I'm working currently on, this overarching research question, whether we can build a virtual agent that learns from human life coders using machine learning algorithms from a large data set of sounds, in this case, this cloud free sound database, going beyond the life coded actions and creating legible and negotiable actions. This is an overarching research question, so the bigger picture, but then looking more close into this issue or problem that I've just exposed, where the question is whether we can build a VA that can learn from the musical preference that the life coder has from a situated musical action, and I'll detail in a minute what we refer to this situated musical action by means of these machine learning algorithms applied to the live exploration of a large database of sounds. So basically, can we train a machine learning kind of model so that we can define what is our musical preference, or to call it more kind of openly, situated musical action? Can we train it based on a situated musical action? So in this case, it would be a noise music context, so no guitars here, right? Or no pitch sounds. And so this situated musical action, that is a direct reference to Lisa Suchman and this idea of the situated actions being or contextualized to a context, and also happens to be this famous book, right, by Lucy Suchman, in the context of also the beginning of artificial intelligence, intelligent systems, and the relevance, highlighting the relevance of the context. So that's kind of a connection. And here the idea is to call this situated musical action to any musical action particular to a specific context. So for this system, here is a little bit of the steps taken, and one has been to identify the machine learning tasks and then implement them with a suitable set of tools, and then implement them and test them, basically. So there are two main machine learning tasks for this project, and so far, yeah, we've been working on this first task, which is about defining what is musical preference, but also more broadly these situated musical actions. So define that from a machine learning task perspective. The second task, which is the current one, is moving that forward. So having like this kind of companion that can learn from the actions of the live coder. But then you need first to define these situated musical actions before moving to a broader scenario where the virtual agent learns from or reacts from what you do. So focusing on this first task, the idea or the process has been to create a data set first of sounds that you like or you don't like. So that was just creating a data set of 130 sounds, using 100 sounds for kind of the training and 30 for the testing, where the idea was to have a broad collection, a representative collection from the free sound database, representing what are sounds that are good or bad in that particular context. So it was for me, so say more in a generic context in a performance, what sounds I would like to use or what sounds I wouldn't like to use. And then the task has been also to train a suitable machine learning model from those sounds to learn what are good sounds versus what are bad sounds. And for this, idea has been to use multi-layer perceptron neural network, and that this has resulted in the default model of the system. So in terms of the implementation, the system is based on this MIRLCA API, which is the new library, if you like. So it's based on the MIRLC system that I've just presented before that, which in turn is based on the FreeSound Quark. So basically the FreeSound Quark is an API that allows you in Super Collider to retrieve sounds from FreeSound, but also retrieve these audio descriptors that you can then play. And then for the machine learning part, the system uses Flucoma API, which is a project based or developed at the University of Huddersfield. And they are developing, the Flucoma team, a set of tools for MaxMSP and also for Super Collider to support this creative approach to machine learning with the algorithms, but from more like using large data collections, typically your own collections, but you can use also for others like FreeSound. And so this multi-layer perceptron, which is the model that is used in the Flucoma library. So you can have both classifiers or also regression models, and they are based on this multi-layer perceptron, which basically you have at least one hidden layer, and then it's quite powerful already, this architecture, to to try machine learning approaches, or to try to train your model. So after some testing, basically the most successful audio descriptors from this data set that was just mentioning, not very large one, 130 sounds. So there were two explorations. So the best kind of approach was the use of what is called mil-frequency cepstral coefficients, MFCCs, using the mean and the variance. And that basically is kind of a description of the sound in terms of the timbre. And that turned out to be working quite well in terms of accuracy. And that's what is the default model of the system for this task is what it's using. And so this is how the neural network looks like, the one that is implemented in this default system. And the testing implies both in terms of the performance, so looking whether that works, for the performer, for the live coder, but there is also another mode, which is based on this interactive machine learning approach, where you can also train train your own motor using this classifier, but live basically as a live coding experience. So I will show you first this performance mode. And I guess if I go here, you will see now the Super Collider screen. Yeah? Is that?
Yes, yes.
Okay, cool.
Yes.
So this is the performance mode, and this is a script that I used this Sunday. There was this transnodal top-lat stream. We were streaming from Sheffield, different setups. So yeah, basically I use that on Sunday, and typically, yeah, with new functionalities, including these credits. But anyway, so how it works now, the system is that when you request, oh, hold on, that's 1 second. So previously, as we were saying, if you type, you instantiate a group first, and then you can request sounds. So now when requesting a sound with the tag jack plus plugin, it will take into consideration the trained model, and then it will return the first sound predicted as good. Oops, sorry again. Let's do. So instantiating the object. Oh, again, so I just changed that. 1 second. Yeah, that's Zoom. Okay, maybe I need to change because Zoom is requiring. Okay, let's see. Then also the times of, there is this asynchronous timing, if you like, of waiting the sound to be downloaded. So it takes some time. And 1 second, it's not playing yet. Do you hear like a little bit of cracking sound?
No, I just hear your mic. Oh, I hear a buzzing.
A buzzing, yeah. It's very subtle, right? I'll call another one. And then you can confirm if that's.
I heard the little buzzing again, yeah.
Yeah, it's taking nothing. Now there is a second sound.
No. Yes.
Yeah?
Well.
It's very subtle as well. I can, yeah, 1 second. Yeah. Okay, and then let me know, I'll retrieve another one and you tell me. So then you can retrieve similar sounds as well. And there is this model also suggesting or predicting a good sound. So let's see if this works now, or you can hear it more clearly. So current sounds are 2 and they are very subtle. Second, because yeah, there is this time.
Okay.
Do you hear it now?
We can hear it.
Yeah.
Like
okay.
somebody's advancing the slide or open the door.
Huh?
The click and the tapping might be on a keyboard.
Well, if you want a keyboard,
no, okay, I got it. And now it's
you got it now.
Click.
It's yes, it's a. There is another one here. Okay, let's try that one. It takes some time just because, yeah, of the internet. Do you hear that?
Not much. I hear a rhythmic clicking and a very low frequency hum.
Yeah.
There we go. Okay.
Now some vibrato. Maybe that vibrato helps.
Yeah. Okay. They're good.
And so, yeah, basically it doesn't look like much. So, okay, you could say, okay, you're just, retrieving sounds by tags and similar sounds, but this is a lot. In the sense that there is some filtering, basically. So there is this filtering and some prediction on good sounds trained from a situated musical context. And yeah, that could go on and go on. Then there is also the way of training. However, I need to change something to demonstrate that. I can maybe leave it for the end, perhaps, because I've been, changing code for the performance. Then all of a sudden the training stopped working, so I have to change to the previous version. But the idea is that you can train in a live coding fashion. Start training by either you get random sounds that come to you, and then you just tag them or annotate them as good or bad, and then also you can combine it or do it either way with sounds by ID. So you might have a list of sounds by ID and you want to really annotate those sounds. So that's possible in the system. Now let me go back to Zoom. I want to see. Yeah, I lost here. Second. Yeah. So I'm going now to the presentation back. Not sure you see that. Yeah.
Yeah.
Yes, sorry. I need to put this over here. Okay, so this is the training mode as described. And in terms of our reach, the idea of this project is to share the tools as long as they are developed. So there has been a little bit of interaction and kind of participatory design with the participants of the workshops. There have been 3 workshops with about 20 attendees. We had to move the workshops online due to the pandemic, a new reality. And so that kind of the goods we could say is that then we had participants from different countries, more than, if we had conducted the workshops on site in one particular place, into a total of 19 countries, 37 cities. But then also typically we split the workshop in 3 sessions, but then it's the Zoom Live, if you like, that yes, I mean, you couldn't see everybody every day because we are all busy. So that was the drawback, if you like, but still it was quite a nice experience having like these discussions with the participants and feedback, seeing them to use the tool and adapting them. So yeah, or go through that, but the main learning outcomes of the workshop were that, first allow the participants to get exposed to the live coding experience, getting familiar with machine learning applied to this context of live coding. And then, all in the context also of Super Collider, being exposed to machine learning from live coding, but again, with the constraints that I mentioned at the beginning of this sound-based music. And outcomes of outreach, there are a couple of videos, also leave them for the end if we have time. So there is now a series of 4 videos from 4 workshop participants who have been adapting the tool to their own practice. which is very, very nice. And there's also a forthcoming concert by the Top Lab Barcelona ensemble using the tool. This is going to be in March. Then also from like this series of videos, there are interviews related on the website. Then we have also done concerts, and there was one hosted by Eclectic where there is a couple of performances and a panel of discussion. This is online, available online. So Gerard Roma was using the tool, and then yeah, it was nice also to see someone else using the tool and seeing the approach of composing. Same with the workshop participants. So this is a stage where it's good to see and discuss with others what are their needs. So there are suggestions of incorporating methods or ideas. So then a machine learning model, what for? So connected to this idea of the situated musical kind of action, if you like. So yeah, there were these different keywords appearing that you can train a music style or a music preference or different instruments, parsing the composition, snapshots of a musical biography, life journey, and so on. So yeah, final thoughts from the workshop. So as mentioned, sound-based music is not everybody's cup of tea. So it might be that, yeah, this is a very particular kind of approach to live coding and music performance, if you like. But still, yeah, you can take it or just take the main concepts, apply it in other domains. So what we realize is that in the workshop is very important to contextualize this approach, our approach with the machine learning early on, so that there are not misunderstandings. But again, so we can always refer to this Bill Buxton idea of the standard spec, military spec, and artist spec. And if we can satisfy the artist spec because it's very, very demanding, then we can also apply that in other contexts. So that's kind of the justification of why this music application can work in other domains. It has been a challenge and still is to work with latest technologies under development, but then again, it's also nice, right, to be kind of at the latest stage and have that conversation with participants. And then also seeing participants taking ownership and moving forward the tool, that's also interesting. From the artistic practice, we have evidence that it's possible to learn from a particular situated musical action, and these different practitioners show that. Then this approach is flexible because of this reason and suitable for different artistic practices. And it will be important also to see how this can apply or accommodate to new methods. Implications for HCI. So yeah, there is perhaps this space that it's important to explore how to borrow tools from HCI for practice-based research, but all the other way around. In HCI research, how can we also bring more practice-based methods that are, like contextualized to particular practitioners, so flexible, but also individual. And then expand this training to other situated artistic actions can be interesting as well. And yeah, this artist spec. So future work, so keep improving the training and performance modes, and now working on this second task, which is more challenging with the virtual, the VA companion, if you like. Then also can be interesting to support multi-user training of a single model and enabling the integration of the tool to a wider range of workflows. So thank you so much. And yeah, this is also a link to another video that we can watch or you can have a look later, but also shows cases. So this idea of the tool implemented or as an ongoing process with feedback from all the participants. So it's really a conversation. And I think it's time, right, for questions or? Just going. Are there any questions?
Yeah, I have a quick question. Is there a way for people to get on like an email list or information about upcoming workshops?
Oh, so the workshops have finished, but yes, there is a kind of mailing list that we are posting all the new, like all these videos, for example, this we call it a series of teasers. So we are posting that, and then information. We have 2 concerts, forthcoming concerts. So yeah, that would be, I mean, yeah, that would be great if you want to be part of the mailing list.
Could you drop the Vimeo link in the chat? I'm not quite able to find it.
Oh, the
on
link
quick
of the
search.
project?
Yeah, we are they are robots.
Oh, the link. Okay, yes. 1 second.
Please.
It's yeah, they are. So this is the concert from. Hold on. Everyone here. Yeah.
Hey, thank you.
Are there any questions or suggestions? Does it inform your research somehow, or I can share like the work from others if that's better?
Now, I have a quick question for you.
Yeah.
And I'm afraid I'm just misunderstanding something, but first of all, thank you. It's really fascinating. I really like the way that you use Super Collider and the machine learning algorithms in tandem with drawing different sounds from the internet. And I'm just wondering, from the machine learning perspective, like at which level it's being implemented. Is it solely to pick and derive different sounds? Are you looking to apply that to maybe learning a bit about how you're interacting with the interface, or at what point does the machine learning algorithm really help you, and where can it go for like in the future?
Yeah, thanks for the question. So there are 2 tasks. The first one is a classifier task. So it has been training this good or bad. So it sounds quite simplistic somehow, but it's required to go to the second task that you are suggesting about learning from what you are doing on the interface. So the second task, the idea will be to do live coding sessions, several ones of them, typing this syntax or sentences you've been seeing in the Super Collider environment, and then listening, or like an agent that is listening and learning from your reactions. So from the query, how do you react? What is the next line of code? And from that interaction and learning process, the idea will be that after that training, the VA will just suggest what you should type after one query or one line of code. So yes, this is the next step that I'm working at the moment, in fact, and you need like this first task, which is more basic, if you like, but then this will allow to, when having the second task address, where we have the VA listening and suggesting a new line of code, it will also consider the sounds that or the situated musical action or context where you've been, annotating as good or bad.
No, that makes sense. And what's interesting is that it sounded like a lot of the live coding contexts that you're talking about are collaborative, right? So you're working with other people. Do you see the machine learning algorithm being implemented independently by each of these actors, or do you see like you using it as a tool to help play with yourself in a live coding context, or where do you think it's most useful?
Thanks for the question. So yeah, initially now also it's based on individual situations, but it's true that there are often times you are collaborating with others and there is a need of maybe training, and why not a model in collaboration. And we've done that in the past in participatory mobile kind of music, where you train gestures with a mobile phone, sending that to a server. So different users train the same gestures, and then you get like that gesture by multiple people. So why not to move also this kind of approach to live coding? So I would say that that can be a second step as well. So after doing some individual training, but yeah, it can be very interesting to explore this multi-user training.
Thank you.
Thanks for the questions.
I have a question also about, I guess, future work or maybe related work you're aware of. The system architecture diagram you had was really helpful because I could see exactly like how Torin's idea could fit into your pipeline. And I'm wondering, at the beginning of that pipeline with the data input, free sound is I did not know they had an API. That's great.
Yeah.
I'm wondering, like, how have you looked into how hard would it be to bring in other data sources, like a sensor array of environmental data or something, or like a live audience?
Yeah, conceptually it should be possible, but then when we move to the implementation side, then it's all there, right? But conceptually, that's the idea, that you could replace the kind of the database. It should be possible to retrieve sounds from the cloud or also personal collections. But then each implementation, yeah, I mean, it takes some time and rethinking. But yes, ideally, that would be also a next step. So it's a great suggestion and idea. And previously in the past, we also compared using, because in this system, we are using the free sound API, as you say, but also the analysis files that they have. They come for you. You don't need to do the analysis, but we compare that with your own personal collection, but then you need to run all these analyses first before making it possible to work in the system. So there should be some kind of pre-analysis of some sort in this implementation part before bringing other databases. But that should be, a very good idea, and it's a matter of implementing it.
Yeah, that's really cool. Yeah, especially because I think a lot of people at this point, they have engaged with kind of an AI judging, like analyzing their personal music tastes via like, Spotify's like yearly review and stuff. So I think that would be an interesting way to bring in community engagement.
Yeah, good point. I'm happy to share a couple of the videos from a couple of workshop attendees, a little bit of video snippets if you want to see. So yeah, that's here. Share this the screen anyway, and we can go here. So we have, for example, Hernani. Hernani attended the workshop at Eclectic, and then we can see Hernani is very much into this idea of live coding from scratch. So really starting from zero, and then the idea here is that Hernani is exploring the tool from complete scratch. So we can see a little bit of this, and also from another workshop attendee, so you can get a complementary vision, right, of how the tool can be used. And then I can show you also another example, whoops, from Ramon Casamajo. So you see two approaches, Ramon using Atom Super Collider, but then the Atom interface or code editor. And also tidal cycles, which is a tool very much used in the live coding scene based on Super Collider, but it brings more, like you can use patterns and more rhythmic compositions. So yeah, you see two examples. Let me stop here. Any other questions or comments?
Yeah, that was really cool.
Which
Super
one?
interesting. Just both of them were really awesome. Just watching the live coding really gets me excited about the. I know it's kind of weird, but whenever I watch something like that, I really want to get involved. Like I want to play music along with it. So many of the like electronic tools that I use are used to like supplement an environment for me to play an instrument. And I don't know, I'm just kind of excited and interested about where that crossover occurs. And I haven't really heard a whole lot. It seems like live coding just is kind of live coding and playing is kind of playing. And I wonder if you know of any circumstances in which those communities cross over.
Oh, yeah.
Interface them.
Yeah, there are several instances, I would say. Alex McLean, you can check previous work, working with dancers, drum player, guitar player. So yeah, I mean, there are other interventions or from other artists, but Alex McLean clearly has been exploring like this hybrid approach, right, to live coding and other practices. So you can check that out. Probably you know him or his work, and if
Yeah, I've heard of Alex McLean, but I haven't checked out too much of the work. So thank you for sharing. But yeah, no, this is fascinating.
So I get, yeah, thank you. Thanks for, everyone for attending. I guess, Ellen mentioned that it might be that some people stay for longer. So yeah, I'm not sure the timing, but I can see many have left. So I guess.
Yeah, and I don't mean to take too much of your time, but if it's like Brody and Emma are still here, and I don't want to monopolize if you guys have questions.
Do you have questions? Emma,
I don't.
Brody?
It's really fascinating. Thank you so much.
Thank you for attending. Brody says, I've never had any experience with this field before. Super interesting talk. Yes, in a few minutes. Okay. So yeah, I mean, I'm happy to stick around, but if you are busy, that's okay too. If you have questions, comments, happy to stay. And if not, thank you so much for your time and questions and interest. It was a great pleasure to be here and share the work with you.
Yeah, very much appreciated, Anna. Thank you so much.
Thank you.
Yeah.
You go on. Sorry, I interrupted you.
No, I was just saying thank you so much. And I've had a really late night last night submitting a paper, so I wish I had more in my head to ask you at the moment, but maybe we could reach out in the future.
Yeah. Thank you for your questions and comments. Yeah.
Of course.
Cool.
All right. Have a good
care.
rest of your evening.
Yeah, you too. Cheers. Bye-bye.
Bye-bye.